What? Yes, I know about the mic. It's better, but not. Okay. And with this, we'll start with the, bandwidth is cool. We'll start with the usual not well. Not well that the not well has changed. The change still reflects the same rules and BCP 79 about patents, if you're aware of any. It's working? I should use this one?
Yeah.
Okay. I can still do noise if I want to. Okay, so if you're aware of any IPR which relates to the work that's being presented here from you, from your company, or even from a third party, please let us know during the meeting or tell the chairs after the meeting. Now, the not well has been improved with a lot more information about best practices, in particular harassment procedures. So, well, procedures against harassment, I would say. So if you're aware of situations, or if you live through situations, now you have a link, this Ombuds team link that you can see on this not well page. These are a team of people that you may contact if there is a situation which requires a discussion. All the anti-harassment procedures are listed in BCP 25. And then we have a code of conduct and rules about copyrights, and all these are now expressed, presented on the not well as well. So they're all here. Reminder, we will, in 10 minutes from now, because there are always people arriving late, we'll be distributing the blue sheets. There will be 2 blue sheets going from the top of the room to the bottom. Please put your email, name and email in there. The minutes of the meeting will be taken. The meeting will be recorded and filmed, so you will be on TV if you're coming to the mic here. If you're coming to the mic, please stand within this pink square that is on the side here, so your smiling face can be seen on TV, and your presence is being logged. If you care, and that would be very nice, to participate to the minute taking, we have an Etherpad page. The link is on the screen above. So that's where all the minutes are being taken. So if you, for instance, you came to the mic, said something, and you feel that what was recorded does not really match what you wanted to say, please go ahead and edit. It's also a good way to track what was just said. If for some reason you could not understand what was just said, maybe the minutes will help you understand.
I just say something. On the PDF that we uploaded, it seems that the link is pointing to IETF 99. So if you, the text is correct, but if you click on it, it leads to a wrong page. So just pay attention if you click on it at 101, like at the IETF.
Okay. And so here are all the links for use by the Jabber participants and the minute takers. And we thank our Jabber. That's Edgar, I guess? No? Oh, it's Raoul? Okay, Raoul is on Jabber, and we have a number of minute takers. So thank you so much, and everyone is welcome to participate to the minute taking. So the agenda for today. So we have a long session and many things to say. So there is this presentation that we are doing now for the introduction. So if you're not happy with the agenda, please let us know now. Yes, oh, that's true. So I guess we'll talk about the hackathon right after my talk before we start the meeting. Okay. So after the presentation, we'll have a small presentation by Dominic about the hackathon. Then we'll go into the status of the Lpwan overview document, which is in the hands of the ISG. Then Anna and Dominic, who is the shepherd of the document, will present the status of the last call of the static context header compression document. And then we'll go through a number of documents which enable the SCHC compression on various technologies. So Julien will present us SCHC over LoRaWAN. Then Juan Carlos will show what he's doing on Sigfox. And Edgar, I guess, or Anna, Edgar will present on NB-IoT. Then we'll have a common session with Diego and Dominic, because there were 2 drafts, but I hope that we end up with one, and we'll see how that goes, about some usage of ICM PV6 over LoRa or over LP1s. Then Alex will tell us about the data model, which has always been in our charter, and we have not progressed well on that, so we can now take over that work. And we'll discuss about rechartering. Any question, anything? So we probably can start.
Okay, so on the status and where we are since our last time that we met. So of course we have 2 charter items as of today. So we have the baseline technology description, which is known as the LP1 overview, and then the compression draft, that is the shake over co-op IP UDP, shake over co-op and IP and UDP. So the milestones are, we have managed to advance pretty well from the last time that we've met, from the last IETF, and the LP1 overview draft, it has been submitted for public to the ISG. So everything is working pretty well there, and we're really happy with our progress, with the progress that we've made. The 2 milestones that we have, the 2 points on which we are working, is the document, the draft shake over IP UDP, and that's the thing that shake for IP UDP, and that's the main point that we're going to be discussing today. And then we'll be talking about future changes to this charter, things to anticipate. So the history, of course, is well known. We have been doing things in a pretty rapid pace. So we had many interim meetings to be able to deliver into this in such a short time frame. And yes, so as promised, we submitted the LP1 overview to the ESG, and things can be going pretty well there. And Pascal will tell us more about it later. And today here, we are going to be talking over this, as I said, the main IP shake for IP UDP. So that will be the main core of the discussions today, and of course the future charter items. So that was the history, and now Stephen, he asked us to step in and to about the hackathon. Before this, we are going to talk about the hackathon. And so during this, during the weekend, just before the IETF, there was this wonderful hackathon, and there were many participants. Dominic will tell us a couple of words about it. I must say that the hackathon is something really important that is getting for the IETF and for the whole community. So personally encourage you, if you're able to come for the next IETF, the week before that, to come and participate. It is really something that's becoming super important, and the hackathon of LP1 has been there from the start and has really helped us tremendously advance and show how things are done and solve outstanding issues. So thanks. I would like personally to thank everyone that was part of this hackathon. It was really a great experience. Thanks.
Thank you.
So just for the participant, and then I will let you. So I'm just showing how we basically can easily get access to the documents during this meeting. So if you go to data trackers IETF.org meeting 101 agenda.html, which is the link I provided in my email for this meeting, you will find LP1 here. Oops, a lot of other things. And the first button here is show material meeting. When you click that button, you end up with this page with the agenda. And if you go down a little bit, you will see all the material in order. And so now we'll be showing the hackathon. Dominic?
Okay, thank you. Oh, remote. Okay. Good morning, everybody. So basically, Alex said it all. Next time, please come and join. Okay. Do you want me to present the other slides? So why should you join next time? First, it's big fun. All of the food is provided. morning, midday, evening. You don't have to care about anything. Just 2 days focus time working on the technology. I really love it. So if your family, your employer allows it, please do come, and you will not regret it, I can promise. The other thing is we include everyone. So even if you think, hey, I don't have an implementation, I don't know whatever MicroPython or JavaScript or anything, do come anyway, because we have little notes, little boards like these ones. We have enough for everybody, especially if you let us know that you're coming, and we teach you how to use them. And you can, we have code in the repositories. You can just download the code, control the little board, and run the code. And as we run the code, you get familiar with the implementation and with the draft, and then we can discuss details and find bugs in the draft. And if you do know how to code Python, MicroPython, then you can help improving the code in addition. But even if you only come to play and run the code, that's good enough for us. So I think that's it. Yeah, we wanted to disseminate awareness practice. That's what we did. We advanced the code a little bit. Two of the participants are really good at coding. They advanced the code quite a lot. The others just, you know, discussed and played and tested, but it's okay and it's helpful. We had one remote participant, Soichi, from Japan, who contributed and stayed there for the whole day, and even though it was late at night in Japan. And so we got this picture in the group photo as well over Skype. Yep. We had, oh yeah, thank you for the companies that provided Lpwan connectivity. Sigfox provided connectivity, and Aclio provided a LoRa network, so we could run real experiments on those networks. We have two code bases right now, one for compression decompression, one for fragmentation reassembly. And one of our goals is to combine those together and have one code for the SHIC draft. Yeah, I mean, you can read the slides for reference, but my takeaway message is next time come and have fun with us. It's really fun.
Thank you very much, Dominique. And this will take us to the next presentation, which is the Lpwan overview. So I'm going to take that.
Yeah. It works. This one works now.
Oh, I will from here.
Yeah.
I won't be on TV.
Oh, okay. Go on to.
Okay. There's nothing much to say, but I can start a bit. Okay, so Stephen had conflicts and he could not be with us to present the status of his document. There is nothing much to say. The progress through the ISG has been very good. And now the document is in the RFC editor queue. So we expect the edit as soon as they can to be submitted as informational. And we're very happy with the document. We got great comments and people really appreciated the reading, so we're very happy with it. Any question? Oh, that's it.
Didn't you have a slide for thanks?
So, Suresh, I see you nodding. Nothing else to say?
So while Pascal is loading the next presentation, which is SHIC for IPUDP, I'd like to take the opportunity to also thank all the reviewers and all the contributors of Lpwan overview document, which made actually an excellent document, and I believe is the first standard body document that goes out, that is published and that actually regroups information, useful information for the main Lpwan technologies. So great job, and I think everyone's super happy for this, and it's a great contribution for the whole community. Thanks.
So the way we structure this presentation right now is more like a discussion. We have Dominique here, who is the shepherd, and Anna, who represents the authors of the document. And basically, since there were a number of problems which were raised during the work group last call, the shepherd will present the problem, and the architect will talk about the solutions, I guess. So let's try it.
Okay, hello. Thank you very much to be here. I will present the history of this last version 10 from last IETF. So we start with version 8, where we start working in the fragmentation part in order to add terminology, to clean the text, and to create the state machine fragmentations. We improve a lot of, we work a lot in the fragmentation part in version 8. Then we create, next we continue working, cleaning up the fragmentation text and also the compression text a little bit less. We put the state machine diagrams in the appendix for version 9. And we start making more integration of compression and fragmentation for this version 9, and we make the last call in December. We start in December. So thank you very much for all the reviewers. We received a lot of valuable inputs from you. We got a lot of work. And with all these inputs, we create the version 10 on the end of February. What is in? There are a lot of many editorial changes because our English is not so good. We reduced the abstract, that it was very big. We create or we finish to complete the terminology section with a lot of terms, abort, ag, layer 2, chic packet, and so forth. We try to integrate more the fragmentation and the compression. Then we create 3 new sections. The first one is chic overview, where we try to show where compression, where fragmentation is done. Well, then we create a rule ID section. It's okay. We create a global rule ID section where we say why or when we need a rule ID. And we create a padding section to give the default solution for padding in the case it will be needed. Next, we also delete or eliminate the window word in the fragmentation modes of operation to only keep 3 modes: no ag, ag always, and ag on error. When we were cleaning the text, we find a lot of error in the fragmentation state machine in ag on error receiver. So we correct this. We update all the headers of IP UDP compress in chic section at the last part. And also we update the chic example for fragmentation. So during this time, we create and close and open tickets. These are the tickets that have been already done during the internet meetings. You will see the first one is rule ID. It comes again and again. I think it's a very good subject to continue working in this group. Well, the first ticket number 2, rule ID default size, was the question to know this space, how many bits it has, how size it has, how is the pattern, how can I define it, and so forth. And well, we were discussing and we said that this document is more about to define compression and fragmentation. And perhaps we'll need a new document to talk about and define this rule ID space. And now it's out of scope of the chic compression fragmentation document. Then we have a ticket number 3, the zip bump, where we add in the security part that when a decompressor receives a lot of information to be decompressed, normally it's not normal, or something that is not normal, he must drop this information. in order to avoid an attack. Then we have ticket number 8. The question was if it was possible to use the same D tag for different rules ID. The answer is yes, because this D tag defines the packet. So I can have different rules ID for the same packet. Then we have ticket number 9, reordering between radio gateway and network gateway. So there was a very big discussion in the last intern meeting about that also, where we define, we say that, we conclude that it's better to say that there is no out of sequence between radio gateway and network gateway, and not reordering in order. Yeah.
So when you say there is no, we assume there is no, we don't
assume, yeah,
make it a mandate to the other technologies, but this works if, this document assumes that no out of sequence delivery happens below.
Yeah, because when we start working in the sheet compression, we assume this part. So we don't want to make a real sequence, to have a out of sequence packets between the radio gateway and the network gateway. Okay, ticket number 7 was, the question was if we need default values for hop limit, for example. Well, I think we don't need any default values for any header field, because when we have a new value in a field of a header, we create a new rule. So a new rule gives you the new value. Ticket number 6, can we partially fill the window in the fragmentation? Well, for all one windows on the last window, most of them, or maybe most of them, will be partially filled because it's the last window, and perhaps it will not be completely filled. For the all 0 windows, we give the best behavior, we will fill the window completely in all 0 windows. But it's not, we are not against to do not fill it. But if you use the partial filled window, it's only for act always mode. For ticket number 4, the DNS lookup, okay? Again, it's about rule ID, how to fill this rule, this context. And I think that this is more or less out of scope, because here we are talking about how we compress the header information and how we get the header information. So I think we need something to define all this part of rule ID, how we create it, how we complete it, which size it has, and so forth. These are the closed tickets. We have a last ticket that is not closed, but it's not relevant. We were asked to give the technology-specific parameters that each technology will need to define in the document, in their document. So I opened the ticket number 15, where I put the list I have created for version 7. And we need to update this list in order to be according to the version 10 or the next version 11.
Okay, so this was the tickets that have been closed during the interim meeting. So these topics have been discussed during the meetings. If you were not part of the meeting and want to understand exactly what the details were of the discussion, you can come to us or read the minutes of the meetings. We decided not to take too much time discussing closed tickets and spare time for the open tickets, which are going to come next. Okay, thank you. Okay, overall we have 26 tickets in the queue right now. A few of them were closed, which we've just gone through. And so this is a ticket that we have in front of us. So we decided rather than take them by ticket number, we would group them by topics and discuss the topics. And we've listed which tickets the topics relate to. So don't bother reading this list. So basically, one topic that comes again and again is the overview. How does that work? There's compression, there's fragmentation. They seem to have things in common, like rule IDs, but the comments we got, the comments you got, I'm not an author. The comments that came up where we don't understand how these two things work together. Can you provide an overview, an explanation? So I think this has been addressed. I'll let you explain what you've done to address that.
We addressed in the new section, in the first section of the draft, we create the section overview, where we put this figure in the left. Here we explain where the chic layer is behind the layer 3, and the functional part is we make compression before fragmentation. Then in the right part of the figure, I explain more in detail the terminology of this behavior. So when we receive from layer 3 an IPv6 packet, it goes to the chic decompression. And here, the chic compression will try to compress it. Even if it doesn't arrive to compress it because it doesn't have the correct rule, it will add a rule ID specified for this kind of problem, and we'll create a chic packet.
So that's terminology.
Yes.
We had one of the issues was that we had no specific name to name this thing that is behind compression and fragmentation. And so the text went about various fuzzy naming, the either compressed or not compressed if it could not be compressed, or blah, blah, blah. So now we termed it a chic packet. So that's a new term that goes into the terminology.
So the chic packet is a real compressed packet, or a packet that cannot be compressed but has a rule ID.
Right.
Okay. And then this chic packet, if needed, if it doesn't fit in the layer 2 PDU, it will be fragmented. And it goes to the chic fragmentation, and it will be cut in chic fragments. So we create chic fragmentation, because before we were talking about fragmentation and fragments, and now we add the chic acronym before in order to join these two parts of chic document.
And by the way, I think we'll capitalize the P in chic packet such that the term is recognizable in the text. So we try to be very specific with terms so we understand what it's been talked about.
So
and
with a lot of inputs we get, after we create version 10, it was not very clear.
Right, I didn't like the if needed here, because what does if needed mean? Who decides if it's needed or not? So right now, what the proposed diagram that will likely be in the -11 version look like this. And so we're seeking inputs if this is clearer, or if we need to do even more. So do you want to explain what happens here?
Then here, when I receive the IPv6 packet, here. Okay. You get it there? Okay.
C'est là. C'est là que Anna.
C'est quoi le pointeur?
Pour le radio, pour le pointeur. It's for
Le
the
laser?
For the laser.
Okay, well,
Yeah.
you can read. Oh, yeah.
When I receive an IPv6 packet, I go to compression. Whatever happens here, I get a chic packet. If this chic packet fits in the layer 2, I did not make fragmentation, and I send it to the other side. If this chic packet doesn't fit, then I need chic fragmentation, and I cut it in fragments, and I send these fragments. When I didn't use this fragmentation in the other side, I only get decompression, and I send the decompressed packet to the layer 3. When I make fragments here, then in the reassembly, SCHC reassemble part, I will get all the fragments. I will make all the SCHC mode, fragmentation modes. And then when I get all the packet, I send into the decompressor. So I don't know if this figure is more clear than the one that is now in the version 10.
Any comment from the room? Does it make the document clearer? I see a few nods.
Okay, so we have a thumbs up from Julian. Let's have a show of hands. Who doesn't think that this is a good thing?
Juan Carlos Zuniga?
Juan Carlos, please.
Sorry, just one quick comment. Does this assume any I don't know, well, is there any assumption about the rule space, the rule ID space?
We'll come to that later. So
okay,
at this point,
so this is
nothing.
independent, and we are not deciding on the space based on this at all.
Not at this point.
Okay.
At this point of the discussion, we are not discussing the role ID space, but we will be, promise, in a few minutes. Okay. More comments? No? So hopefully this time people new to the draft will see this drawing and say, okay, I understand what's going on and between compression and fragmentation. If this is still not the case, tell us and we'll try to do even better. But
so about the way to proceed here, there are quite a lot of open issues. So what I would say is, because I don't want to make everyone vote for like 10 times in the next 30 minutes, in case you feel that you are not clear on this, or in case you feel that you're against something that is said here, please go to the mic or raise your hand. And this way we'll know to go in discussion. Otherwise we say, okay, well, you consider that this is okay and that the solution that is proposed here is okay for you.
Yeah, if I can just add, we have a lot of material to discuss. So if we can have a quick feedback, like, yeah, no, just a few nods, that's good for us. Otherwise, if the whole room stays silent and we go to mailing list and it takes a month.
Question from Soichi. If you receive a packet from the other, how can you know the packet is a fragment or compressed without fragment?
Can you?
It's the rule ID that gives you if it's a fragment or if it's a compressed packet.
We'll come to that. We have a few slides on it.
A few slides about that.
So
But
this
it's rule ID that gives you the difference between a fragment packet and a compressed packet.
It will be discussed in details, gory details. So still on a topic that has raised many comments is terminology. We don't understand, how you name things. And so, as we said before, we've decided on SCHC packets, SCHC fragments. We will capitalize packet, and we've decided on compressed header. Compressed header is what is achieved after compression of the packet coming from the upper layer. SCHC is header compression, the HC. So we're compressing the header. We're not compressing payloads, which was not always understood. So we have now we are going to define a compressed header as being what results, what comes out of the compressor. And the compressed header is composed of two things. One thing is a rule ID, and the rest that we need to transmit is called the compression residue. Hopefully, in the best case, the rule is so well adjusted to the packet header that needs to be compressed that it's enough to send a rule ID, and the rule ID tells everything about the compressed header. In some cases, there are a few bits that are not totally defined by the rule ID, and those bits will be sent, and this is what we call the compression residue. So that's the compression layer. And then below it, we have the SCHC fragments, as Anna said. And the fragments will send, the fragment payload will be parts of the SHIC packet, including the compressed header. And of course, we have fragment headers, and they contain a few things that are described in the fragmentation section, such as a rule ID, DTAG, etc. So hopefully, we came up with this drawing for this presentation, but we'll probably put it in the draft as well, in ASCII art. Good fun. Any feedback on that? Does it make things clearer? Not sufficient? If we put this in a draft, is everybody happy as far as they understand what is going on here?
Juan Carlos Zúñiga, my suggestion would be to simplify a little bit more even this, like if you just, instead of repeating the fragment, just define one fragment and then you put dotted arrows or something, because otherwise it's a little too busy.
Okay, maybe the second one is not needed, but...
Yeah, maybe the one first, last or something.
Okay,
thanks.
Thank you. That's good feedback. So far, we had ACK being described as a special case for a fragment. And I think it was kind of confusing because a fragment goes forward between the sender to the receiver. And we have this ACK going backwards from the receiver to the sender. And so the way it was described so far was the ACK was a special numbering of a fragment, but then, you know, things get confusing. So we decided that we will coin a new term, which will be a SHIC ACK, so that we don't confuse it with the ACKs at other layers. And it will have its own name. It will no longer be described as a special case for a fragment. And so the encoding hasn't changed, but it will be called the SHIC ACK. One thing also I requested is that we didn't have a name for a line in the rule table. And again, the text went about, you know, different ways of naming that thing. And so we called it a field description in the table. So we can refer to it with its capitalized name. So I think it will, again, makes the text clearer. Okay, why is it terminology? I don't know. Okay, they were probably the title.
Dominic,
yeah.
if you go back, please. It's George from EMT Atlantic. SHIC ACK is for SHIC packet or for SHIC fragment?
For SHIC fragment.
Okay, because I mean,
we only use ACK for the fragment.
Okay, fair enough.
Right. Right. This is true. I think on this diagram, but I mean, your point is welcome. Maybe we missed something, but here we have a SHIC packet. If the packet doesn't need compressions, there's no ACK, because we don't care about that. That's not our issue. If the layer 2 wants to do ACK, if layer 4 wants to do ACK, that's their problem. But if we do fragment, then it becomes an array of SHIC fragments, and there we have a few reliability mode, 2 modes that do involve ACKs. So they are SHIC ACKs. Do you think we should add SHIC ACKs on this diagram with an arrow going backwards? I see yeses. Okay, good point. We'll do that.
Maybe it's only for me, again, George from EMT Atlantic. What about having a small condition just before the if no fragment, like saying that if fits to L2, then transmit. If not, go back to the fragmentation.
Yeah, good point. We were discussing having this little diamond shape, and
I think it will be more helpful and more clear, you know.
But in ASCII art, it's hard.
Okay, ASCII art. It will be good fun.
No, soon.
Hi, Edgar Ramos from Ericsson. We have had that discussion in the interim, and the problem is that depending on the technology, you might not even want to have fragmentation activated at all, because you could have fragmentation in lower layers. So then, I mean, why you have fragmentation or not, maybe it would be good to be left out of the document and leave it in each technology document.
So yeah, to answer your point, actually, when we drew this, we had your case in mind, where this upper arrow saying transmission, if no fragmentation included the case if a given technology does not want shake to do fragmentation, not just that the packet fits into the actual frame. So the if no was vague enough to include Edgar's case. Now, if we go your way, adding the diamond shape, then maybe we need to have another thing saying maybe you don't want to do fragmentation.
Suresh Krishnan. So Edgar, just to confirm, you're saying like the decision need to be made after the input pipeline, or like the technology can decide based on its MTU whether it wants fragments or not, right? So the input to this pipeline is an IPv6 packet. So you could have decided before that, right?
Sure. The problem is, this is Edgar again, that, for example, in narrowband IoT, you could have basically no MTU limit because you can segment in the lower layers. So if there is any segmentation, the optimization is done by the lower layer. So you don't need to already add headers on top of that. So then it makes sense not to have fragmentation in certain transmission mode.
So would it be a fair description if we say the packet fits into the L2 PDU because basically the PDU is an unlimited size, but you have another view of what the L2 PDU is, I guess.
Yeah, the problem is that, for example, for narrowband IoT, you have link adaptation, which it means that the PDU size is not known until transmission, a couple of milliseconds before transmission. So then it would be pretty difficult to adjust this all the time. So what is the maximum size that you are going to have? So
what would be a good term to describe the fact that the packet does not need to be fragmented by shake because you can take care of it whatever its size is? What would be the right term? We attempted to say L2 PDU, but we understand that L2 is, I mean, you are above L2, so, and we are below L3, so.
Dominique, if you just say if fragmentation needed, blank, I mean, and it's not this document.
But needed was too vague.
No, just for this document, it's okay because there are specific documents at that.
So
I'm happy with the if needed, but
Chair had just a short question about the purpose of when this was asked. If my memory is correct, was just for people to visualize how the process is happening. So yes. I would like to, I mean, I would keep this in mind and not put too many complexification in the picture, because people, they say, okay, well, you know, there is this thing. I would like just to have like a big picture overview without going down to the nitty-gritty details. So is it, I mean, there is maybe something for you to consider, and for Edgar and for everyone, like, is it okay to leave it simple and have some star and then say, well, you know, if blah, 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 add the ifs, but at least have the picture pretty simple for people to grasp very rapidly. Okay, first I do the compression, then, you know, if I need fragmentation, then I do the fragmentation, and then, okay, if I need, then I need to define, and that's in a different document.
So basically we're discussing between this picture to the right, that picture on this slide, and an even more detailed version of that one with a diamond shape and explaining the decision. So that's the three options we're discussing right now.
Well, what it means if needed fragmentation, that might be like maybe 3 lines in the text that it says if needed fragmentation is up to, you know, each of the documents, but majority of the case would be fit in if it fits an MTU. So it could be something like that it says kind of a default that it would be fitting the MTU, but then also clarifying that it could be meaning something else in these other documents.
Okay, that's one point I hear there.
Suresh Krishnan again. So I like what he said, but I don't want it to be in line of this text. Like maybe you can say like if fragmentation is needed as per whatever, and just point out somewhere else. Like, because it kind of like completely messes with the flow of like people reading it if you have this big explanation. So I really like it. You say like if fragmentation is required as per appendix A1, and then you can probably put in like, oh, the link layer documents can specify whether and then be done with it. And I like this picture. I think it's
this one here.
Yeah.
Okay.
So
it's probably a midterm between the.
It still shows there's like a decision point to be made there, but not explaining about like why or all the details about that. So that's good enough for me.
Good point. Thank you.
Juan Carlos Zúñiga, yeah, well, I guess just supporting the Suresh and Alex points, I understand well Edgar's, and perhaps I would have other constraints with Sigfox. So if we just add it to the list of to be done by layer 2 specific documents, and then we point to there, it'll be clear to say, okay, well, this is not known. I have to see what is on here, and then
Forward
we get
reference.
all the reference. Yeah.
Okay. Thank you. Okay. MSB, LSB. So the comments we got about that is the text is a bit unclear. What do you mean? What is X and Y? So just to recap, for those who haven't been following closely, we have a matching operator. So we have the incoming packet on the top. We match it against a pattern, which is a target value. The matching operator we're talking about at this point right now is the MSB of X operator, which means that we're testing if the field value that is presented to us from the incoming packet has the top X bits equal to the target. If it does, then the rule applies, and if everything else matches in the rule, we go to the compression action CDA, and we do something. And actually, you don't have to have the CDA LSB when you use the matching operator MSB, but it's what it's meant. I mean, they are meant to work together. So this is the normal situation. And in the document, we say we match with X bits, and we can send Y bits. So the people were confused about X and Y, and you know what happens if X and Y are disjoint and there are missing bits in the middle. And the draft currently didn't say that the target value has to be at least X bits, otherwise you don't have data to match the packet to. So Anna, what's the situation here? Can you explain us how this works and what the draft will say?
Okay, when you have MSB X bits and you have a matching operator MSB, you will know the length of the field, and you can compute the Y because you know the length, and you send the residue in the SHIC packet. Oh, sorry.
So you're saying if Y is absent, because this is
Y
an
is
option.
yeah.
This is allowed by the draft that the rule does not specify Y. It's a simplification. And in this case, Y will be the complement of X to the field size.
Yeah. When the length is known and the field is fixed, has a fixed length. When the length of the field, the header field is fixed, you know the length, then you don't need to specify the length. Then you can compute Y with X on the length that you know.
If Y is not specified. Now, if Y is specified, then you will send Y bits as a residue.
Yes.
Because that's what you want. And now, if X and Y do not add up to the field length, then what happens?
Go to your next slide.
No, I was still on this one. If X and Y don't add up, well, if there are bits in between.
Okay.
No, next one is a variable. So if X and Y don't add up to the field size, if the total is smaller, then there are a few bits that will not be matched against. So they are don't care bits actually. And they will not be sent either. So they will be reconstructed from the other side. And so basically you're replacing don't care bits by a priori bits on the other side. So you have to know what you're doing because you are actually changing the packet, but this is allowed by the draft. Does anybody have a strong objection to that behavior? Does anybody not understand what this is supposed to work?
Pascal, did you find, Pascal Cisco, do you have a particular case where you use it already? The hole in the middle? Because I was thinking about reserved fields, and when we have a reserved field, usually the rule is like you must set it to 0 and ignore it, if you don't know what's in there. And so it looks like the default behavior of filling with zeros could be like a reserved field, but if you think about other use case than reserved, then maybe it's a different value.
No, Toutain, this is, we are in a very strange case. No, I never see any case where you can apply this. And if you have reserved bits, so you know that they are in 0, so you can extend the x to reach the y. So for when you do the comparison.
Well,
so,
you could say the bits are reserved, but in case I get some value that is non-zero in there, I will replace them with 0 anyway. They are don't care on input and force to 0 on output. So that would be the behavior. So my question is, we are specifying X and Y, and we're introducing this kind of weird situation. Do we need that? Or do we just simplify the draft and the mechanism by saying there's no Y at all, and Y is automatically the complement of X to the field size? Okay.
Alexander here. So what I would say here is that you could imagine that you could use in the LSB in other contexts, independently of the MSB at some point. So it's good to be able to specify LSB, like to say, okay, LSB takes a parameter and it takes the least significant bits. Then I would go with something like, if it's necessary, either go Pascal's way, say, okay, well, others should be 0, or maybe they can be taken from the target value or something. But I don't have strong opinion on this, so it could be really as the room decides. I would feel that it's good to have it as it is, like the minimum changes to the draft, and if you feel that there must be some developed values, then set it to 0. Otherwise, if it works for this, then it's okay for me.
Okay, so I'm hearing that this is okay. You're suggesting not to change anything. Does anybody in the room think that this is really a headache and it's no use, so we should change it? Raise hands. Nobody. So yeah, just leave it this way. We'll try to, we came up with the drawings so that we are able to explain it to you. These drawings aren't in the draft right now. This is why I think people were confused. So I suggest the authors put this drawing in the draft. So
yeah,
it's
if I
easier to read.
I would like to have text in the draft that specifies that we put zeros, but otherwise it's fine for me.
That specifies that we put
What
zeros?
do we do with the value that could be there? I mean, if there are some bits that are not accounted for, whether we put 0 or what do we do? I would like to have something like that in the draft, maybe.
Well, the way it's written, I think it's clear. The missing bits are filled from the target value. Now, the point is, if the target value is not big enough, it falls in between an X and Y. You may be missing bits to fill the other side with.
But in the specification currently, we don't put the argument. We just put LSB, and it means that we compute the default value. Alex just said that we put 0 instead of X, instead of Y, but I think it's better to remove the argument in.
So you're saying don't put Y anymore, and we only have the
LSB.
behavior that's explained on the bottom line?
No, just put LSB without any value after.
So what? So this behavior happens, right?
Yeah.
And so we do not allow the X and Y disjoint.
No,
field.
in the CDA, we just have LSB and not LSB parentheses in something.
Okay.
No argument.
Okay. So we always apply this. Yeah.
So
if Y is not there,
okay.
if absent equates to this. So you're saying we make it absent. So okay.
Okay, just for timing, we are at the half of the slot that we have here.
Half of the time slot. Okay, interesting. Okay, if you thought this was complex, now we get to the real meat of it. Because, because this was all with fixed size fields. And now we have variable sized fields. So why do we have variable sized fields? The group wants to compress CoAP. CoAP has URIs. URIs are variable in length, contrary to IPv6, UDP, which have fields that have well-known sized. You know it in advance. If it's going to be IPv6, you'll find so many bits for this, for that, for that. Now we have CoAP, which has the options with the URI options, and those are strings that can be of any size. So now we need to do matching on variable size fields and compression of those fields as much as we can or want. Right now, the only case we have for variable length field is CoAP URIs. So it was kind in the mind of the authors that this was the only use case. And I mean, the explanation was kind of driven by that assumption, which may not have been present in the reader's head. So we're trying to explain what's going on here, and then we'll decide what we put in a draft. So let's take the case of the URI needs to be transmitted. It's random, and we can't elide it in any way because we don't know what's going to come. So then we would use a matching operator, which is ignored. So we just ignore this field value, and we use a CDA, which is send it. So we will send as a residue this field value. Now, because it's variable length, we have to tell the decompressor what the size of this residue is, because it can't tell from the rule. So it needs to pass this SHIC packet that's coming in, and it needs to know how many bits are in this residue, which is a field value. So the draft says we send a field length so that the decompressor knows how many bits is a residue. Because it was meant for CoAP URIs, and URIs are strings which are 8-bit bytes, the draft currently says the length is expressed in bytes. So everything else is bits. SHIC says no alignment whatsoever. Everything is bits, except here, which is we treat data, byte aligned data. And so the length is a number of bytes. And this got people confused. Why is it bytes? You said it's only bits. So this is why. Of course, the authors could make it bits, but in most use cases, you would have three extra bits to number bits, and the number would always be a multiple of 8 anyway. Before I let you interject, Laurent, I just want to explain one more thing. The length is sent before the residue, and the author decided the length can be extremely variable. You can have small fields, small URIs like 1 character or 3 characters, and you can have long ones like dozens of bytes in your string. And so what size should be the length that is sent on over the wire? Should it be 3-bit, 5-bit, 6-bit, 8 bits? If you make it too big, then you're wasting bits. If you make it too small, then you cannot encode longer values. And so the smart idea was that the length will be variable length encoded, like CBOR, for those who know CBOR. So if the length is a small number, it will take few bits on the wire. If the length is a large number, it will take more bits. And so the draft explains this encoding, which is not the same as CBOR. And so now the draft talks about the length and also talks about the length of the length. And that got people confused, and I can understand that. Yeah, and I say, and if the field was a length field, like IPv6 length, then you could also be talking about the length of the length of length. But luckily, this doesn't happen because the length is a fixed length field. Okay, now I got your attention. So yes, now we understand the draft is a bit difficult to read. Now, there is another situation. Yeah, I said
just a question here. So, what is the solution here? So the problem we understand.
Okay, we're just explaining what happens. And again, if you strongly object and say, no, we want length in bits, not bytes, because I have a use for a variable length field that is not bytes, tell us. Or no, I want bits because on a philosophical ground, I want everything to be bits, tell us. Otherwise, things are going to stay the way they are. The thing I'm doing here is explaining how it is right now in the draft if you have attempted to read it and not succeeded.
I just want to add that normally when you define the rule, you have a length field at the beginning that tell you the length of your fields, of course, and it can be a number, so it's a fixed length, or you put a keyword. Currently we define var to say that it's a variable length. And it's not in the text now, we have to add it, but we have to say that the unit is bytes. But we can also create another keyword that could be the length in bits. So, and then we can apply the same process. So it's not a radical change in...
Right, you're saying if we change mine later or we discover a use for variable length fields that are not byte aligned, we can always introduce it later without disrupting, without breaking anything.
Yeah. So why is it different from CBOR? Why should it have to be?
It's different from CBOR because in CBOR you have small values, and then you say it's a byte, it's 2 bytes, it's 4 bytes, etc., etc. But here, in fact, what we want to do is to be to the closest on the smallest value. And so we don't want to waste the smallest value to say it's 1 byte or 2 bytes. So we go to the end, and then we extend to 1 more byte. So we want to have only small value because it's stupid to send long URI when we want to send an Lpwan. So normally people will focus on small values.
Okay, so I've described the ignore value send, which is we get a URI, we have no idea what it's going to be, we didn't want to burn dozens of rules to match anything, so we just ignore this field in the matching operator and send it. Another case, which is very similar, so it doesn't need more discussion, is the MSB-LSB pair, MO and CDA. So we match the first characters of the URI and send the rest. That's easy. Now we get to another one, which is you are expecting a few possible URIs, like foo, bar, or index. Foo is 3 characters, bar is 3 characters, index is 5 characters. And that's the only 3 URIs you're expecting. Anything else you don't need to process, you can drop the packet, or we don't want to optimize that. So you have a variable length field, which is a URI coming in, and you're expecting 3 values, 3 potential values. So the basic mechanism in SHIC is to use match mapping and mapping send. So you look at the incoming packet, see if the field value is among a list, the target value being a list in the match mapping operator. And if it is among the lists, then instead of sending that field value, you send the index into the table. The table is known as the receiver. So from the index, the receiver will be able to reconstruct the field value. So the residue in this case is going to be the index into the table, not the value. And the index has a static length. It's known from the other side. So we don't have to send the length because the index is a fixed length. So again, this was a confusion in the draft that we talk about the incoming length, incoming field that has variable length, but then we don't send the length on the wire, even though the incoming field is of variable length. And this is because the index is of static size, known size.
Dominique?
Yeah.
In some of those, well, some of the pieces of the strings that you're carrying there may be case sensitive and some of them may not. And so do you have a matching on case sensitive field versus non-case sensitive field? I don't think you do, that's why I'm asking.
Okay, I heard you said
You have a neural, right? And there is a DNS piece and there is like a the rest of the path. And maybe the DNS piece is not case sensitive.
Right.
And so you don't want to have a matching operator for every possible variation of cases.
It's a huge
And-
combinatorial. So what do the authors
Well,
reply to
well,
that?
yeah.
I don't know. I'm not.
Currently, we are case sensitive. Currently, we are case
Okay,
sensitive.
So is there a way
Currently,
to
you
autom-
have to put both in the list. For example, if
It's
you are
not-
using matching
It's
match
not
mapping.
both. It's 2 to the power n.
Yes,
If
it's
there
a
are
lot.
n characters.
So basically the idea would be to have a match which is a character match which is case insensitive, and you do a bit match if you're case sensitive as you do today. So that would be a different matching operator, which would allow to have a case independent thing.
It's not only matching operator, it's also, it's equal, that has to be modified too.
Yeah.
Well, you find the best way, but
Okay, I think we should take the point. And okay, so this is about variable length field. Any comment from the room? Those of you who have been following that. Any recommendation to the authors?
So a question here. So here you're presenting that there was ambiguity in the text. You applied some modification to the text, and now you consider that it is more readable, right? If I understand correct.
I'm saying I don't think there were that many people who really could understand what's going on with the text. We spent about 6 hours in the previous 2 days to make sure everybody around the table agreed on what actually was going on.
Okay.
And we tried to capture that in the drawing. And now I'm expressing this over to you, and I'm asking if everybody is happy with that behavior. If I get a yes, then the authors will try to capture that understanding into a document that is legible.
So Krishnan, so I think the text in the draft is wrong. It doesn't capture a condition properly, okay? So the condition is length 255. So if you have 255,
There's a mistake on
Yeah,
okay,
255.
that's cool.
an
Okay,
one.
so I think if you just like drop it to 254 and
Yeah,
then the other
that's
ones,
it.
then we should be okay.
Yeah, this is captured already. Thank you.
Question from Soichi. So the size of the index must be defined in the rule table. Is that correct? So the size of the index in case of
Yes,
If you
the
should be
rule
defined.
table has a target value that is a list. And the number of elements in the list tells you how many bits you need to encode the index. So this is implicit in the field description. You can make it explicit if it's a list. Okay. So again, if you have strong objections to that, raise it now or on the mailing list in the next few days. Otherwise, this is what we are going to try to write in the document. Okay, rule ID. Haha, now we come to the real debate. So, yeah, we got these comments over and over again. The draft doesn't specify the size of the rule ID. So I'm going to reveal some breaking news to you. Actually, the draft doesn't even mention any numbering system. People have been assuming, including myself up to 2 days ago, I was assuming that there was a fixed size rule ID. Not that the size was defined by the draft, but that the draft assumed that the size would be fixed and the number of bits would be defined elsewhere. But actually, they opened my eyes by telling me, well, it doesn't have to be a fixed number anyway. So what does the draft say? So what is actually the purpose of the rule ID? Anna, can you tell us why we need rule IDs at all?
The rule ID is needed to identify the compression rule all the context for compression. It's needed for identify the specific mode of fragmentation and the settings of fragmentation. And it's at least we need perhaps one rule or more than one for the case where compression is not possible and fragmentation is not needed. And then we have an IPv6 packet and we need to have a rule ID for this specific case.
Okay, so yeah, maybe jump back to this one. So actually, the rule IDs are just there to tell things apart. When you are the receiver of there, how do you know what you're getting on your, layer 2 payload? So it could be either a compressed packet.
Yeah.
So you have a rule ID, and the rule ID tells it's a compressed packet, SHIC packet, and this is a rule to be applied to decompress. Or it could be a SHIC fragment. You have to be able to tell it's a fragment. And if there are multiple modes, window modes,
always
reliability modes,
each mode has a rule ID
and window
different.
size,
Yeah.
you have to be able to tell them apart. That's why we have rule IDs, so to be able to identify what we get on the receiver side. But there's absolutely no assumption on how do you tell them apart. As long as you can tell them apart, you're fine. And so you could use any numbering system. You can use entropic coding, variable length, open numbering to the right, could be anything. So the draft does not assume you've allocated a fixed number of bits. It doesn't tell you how many bits, but it doesn't even tell you that there's a fixed number of bits.
Yeah, Edgar Ramos again. I think it's important what you're saying that it's not specified as a fixed number, because otherwise, if you have a packet that is not compressed, and you need to attach to that a rule ID, so actually instead of compressing,
yes,
we are adding more overhead.
Yep.
So then something clever has to be done, maybe technology-wise, to indicate that rule ID is actually meaning that there is no compression, and then try to reduce the overhead to the minimum.
But rule ID could be 0. Could be
1 bit.
Could
You need
be
at
1
least
bit.
1 bit.
Sure, but then, yeah,
If you-
exactly.
if
You
you
add
think
1
this
bit.
is- if
But
you think
many
this is
times
frequent-
by adding 1 bit, then actually you're adding a byte because, because the octet alignment and so on. But I mean, it was just an observation. I'm not really fighting against this. Just that to keep in mind that then that's a consequence of this.
Right.
And it's good to keep it in some way free so that it can be found a clever solution. Yeah.
So it's a recommendation you're making to the technology-specific document, because
Exactly.
this only tells, and I'm here to try to have a draft that expresses these things clearly. We're going to have a draft that says you need to tell things apart. That's it. How you do it, not
Yeah.
this draft.
So I'm supporting what basically you're saying. Yeah. Thanks.
And what got people confused is that in the draft we have these figures 9 to 23, which is 14 figures that I found confusing because they had this R value, which was the size of this fragment header, and T is a constant, N is a constant. It's explained in the draft. So I was kind of assuming that R was a constant as well, but it doesn't have to be.
Well, everything this is a fragmentation header, and anything is fixed at but W, that is 1 bit. Because rule ID has not a fixed size, DTAG has not a fixed size, and FCN has not a fixed size. So it depends what you are choosing to do, that you have this R larger or smaller. So when you look at this, of course, as you said, we can get confused to know if R is always the same size all the time or not. So perhaps we can, what do you think of removing this R and put it fragmentation header instead, or?
Yeah, the current recommendation within the group of authors is to remove R because it's confusing and eliminate any risk of confusion that is a fixed size. So that's a proposal. And do you think of anything better the authors could do? Hearing none, so
Okay.
yeah.
Juan Carlos Zúñiga, I'm not sure you're hearing none. It's just we're trying to digest what you are explaining, but at least that's my case. So what you're saying is that the values will, I mean, I understand that there can be different sizes of FCN and the rule ID itself, but what you're saying is that they will vary in time over the same technology and the same connection? Or?
No, it will not vary from the same packet, but it will vary from different packets.
Why?
From
Like what is the advantage of that?
It will vary from one rule ID to another. So you can have a rule ID with FCN of 3 bits and another rule ID with FCN of 4 bits, for example.
we are in fragmentation. And for compression, we can vary from rule ID. And different packets has a different rule ID with a different size. But here in fragmentation, all the packet that is fragmented will have the same rule ID, TTAG, FCN size. All the fragments of this packet that will be fixed in a certain way.
Your question was, does it vary over time? If you're processing the same thing, it does not vary over time, but you can have multiple fragmentation modes, window sizes, and so you would have different N values if you're using one or the other.
But for one rule ID, R will be the same for the same rule ID. Is that what you're saying?
For the same rule ID, you can have the same DTAG and the same FCN.
So you may choose to have a different size if you have different rule IDs, or you may not. You may decide to have the same and simplify things a lot.
Well, it's a general. For example, if I have rule ID 1 with DTAG 3 and FCN 2, I can have rule ID 2 with DTAG 4 and FCN 5, and then, well.
No, the confusion in the document that you think that for anything, everything will be R bits. And it's not R is something that varies from one rule to another. It's not constant over the rules.
That may vary.
May. Yeah.
I mean, the draft doesn't prevent it from happening. And we don't want to convey the impression that this is the case.
This is Diego from Universidad Diego Portales. The question is this should be defined, the size of the rule ID and the numbering of rule IDs within the specific technology itself, or they will be for the implementer?
It could be both. I mean, technology will give you the, I don't know, the behavior, more or less, what you have to do. They will not tell you exactly how you have to implement it, but in the implementations can do.
Yeah, one example could be on LoRa, for example, there's this specific byte that's called the F port. It's there anyway. It's not costing anything. It has some reserved value, but as long as you use the unreserved value, it's free. So you could map rule IDs onto the free values of F port because it doesn't cost more. On some other technologies which don't have this kind of F port byte that's special, you're eating into your payload, and so you want to be very thrifty in the number of bits you allocate, or you can do entropic coding or whatever. And if you're doing an interoperable system, you'd better have the two ends agree on this thing. If you're doing a private network, then you can design your own.
Okay, thank you.
Actually, Catalano from Kelning. My question is maybe dumb, but how do you get the rule ID size when you have a variable rule ID? So if I make a parser, how do I find out where to stop to get the rule ID length?
Well, if it's entropic coding or variable length encoding, then you have to look into it to know what its size is. That's,
So it's described inside the rule ID itself.
I mean, if a technology, an implementer decides to make it a fixed number of bits, then you don't have to look at the value to know the size. If it's decided to make it otherwise, you may have to look into the value to know the size. That's just regular coding.
If I look better over here. So yeah, for me, it's from the context, you could know what are the possible row IDs, and then you might, of course, try to see which one match, and it's up to the creator of the context to be sure that you cannot match two at the same time.
Right. What this draft says is that you need to be able to tell things apart. So if you use a bad numbering, you create ambiguity. That's all this draft should say. All the rest is left to technology or implementation.
Thanks, Juan Carlos Zúñiga. So I originally had the same concerns as Julien. That's why I was asking, if it's May. So at least personally, I would say just clarifying this document, that it's a May. You have that flexibility that may be useful for some people, and for some other people may not be useful at all. So it's just clarifying that it's not one or the other that we are forcing.
Yeah, my recommendation to the authors is to be explicit as to why we need rule IDs, what they are used for, what their single purpose is, which is to tell things apart, and leave all the rest to the other documents. And maybe we can have an appendix that suggests things like a fixed number of bits or anything.
Suresh Krishnan. So I don't understand what the issue is. The draft currently says this is technology specific, R is technology specific, and it's defined elsewhere. So what are we trying to fix here?
No, we're just trying to explain that R may not even be a constant.
For a technology?
Yes.
Okay, then I have the same question as Julien and Juan Carlos, right? Because either we say like just leave it to the technology and let the technology figure it out, and they explain whatever, right? Just say like R is whatever the technology says and handle it in the technology specific document,
Yes.
whether it's fixed or not, because somebody might want to keep it fixed or not. So let's not even go there. The current text is good. I don't want to change anything.
The thing is, that's my personal opinion. I don't like R being there at all because it kind of conveys the idea that it's a fixed size. And I personally, I would.
There's no text in there. It says it's fixed or constant or anything like that at all.
Right. But it's just.
And it constantly repeats that it's not a multiple of 8 bits. That's all it keeps saying. But yeah, got that, right? But other than that, I see no indication that it's fixed at all.
There is no indication.
Yeah. Well, okay. So
No,
maybe.
but that's my personal opinion, right? No AD hat or anything. But like, I don't see a change to fix. But if you start taking this out, then provide some indication to the like link technology people, like what they need to do to specify this. Otherwise, just leave it as is.
Right. That was ticket 15, that we need to specify what technologies must specify. So this is taken care of. The one thing I'm personally opposed is having this R character in the diagram because it conveys wrong ideas. But that's the only change I'm suggesting.
That's not the time. That's just the screensaver.
Time out.
Okay, just Carlos Gomez. One thing to keep in mind anyway is that the rule ID for header compression and the rule ID is used for fragmentation share the same rule ID space. So that's something we also need to keep in mind in all this process.
Right. So yeah, this can be another discussion, but right now they share the same space, and that's why I'm saying you need to be able to tell things apart. And what you just said is that they share the same space is actually a consequence of what I said. You need to be able to tell things apart because you can be getting a chic packet and fragment it, or you could be getting fragments, and you need to be able to tell things apart. So you have a rule ID, and they belong to the same space because you could be getting one or the other. That's it. And okay.
Dominique, you're already out of time, but since your chairs are so generous, we're giving you 10 more minutes.
Thank you.
Since you deserve it so much.
Okay. One more topic, padding. We got lots of comments about padding. Yeah.
We have also discussed a little bit in the internal meetings.
Right, right.
And what we decide was to not make it mandatory. It depends on the layer 2 technologies. So what we specify today in the version 10 was default padding that may be used if it's needed for these technologies, or they can use anything else.
Okay, so maybe let's speak openly. There is one technology out there, which is Sigfox, that has a forward payload that's not byte aligned. We know one. It's Sigfox. So yeah, I mean, it's part of our target. So they can transport any payload of any number of bits, not bytes. So we don't want to constrain any alignment in the SHIC document because, why waste bits? Every padding is unused bit that's being sent on a wire. So what this document says and aims at doing is not being aligned on anything, only bits, of course. So that's the intention. And actually, I personally think that the document could be better because it does talk about byte boundaries here and there in the document. So I'm advocating for it to talk about natural boundaries for the underlying technology, which might be bits in some cases.
So Juan Carlos Zúñiga, Sigfox, just clarifying because we had a small but perhaps a little confusing text that I just recently updated. So clarifying on the way it works, in Sigfox you can send either 1 bit or bytes.
Oh,
so
okay.
so I tried to add some text,
Okay.
and that's in the uplink. On the downlink, it's an 8-byte
That's fixed size.
constant.
Fixed.
So we have to treat it differently.
Okay.
But coming back to your point, in the uplink we may need to pad up to 1 byte.
Okay, so it's not any bit alignment going uplink, it's only 1 bit or a number
Right.
of bytes.
So
okay,
right.
so it makes it simpler. Okay.
And
Anyway.
Dominique, maybe also when you talked about the co-op and things which is counted in bytes, do you imagine that people would shift that? It seems that at least the variable byte aligned, strings of variable lengths, they should all be byte aligned, right?
No.
I don't see you shifting those things, would you?
Yes. Computation is free compared to transmission. I mean, the ratio 1 to 100. So yes, you will do shifting, for free.
Suresh Krishnan, so not like related to any specific thing, but I found the issue tracking to be a bit difficult because when you said for the last one, it's in issue number 12, right? I think it would have been useful if you had a real issue tracker, and I offer to set up one with, because it's like everything is just on the mailing list and it's hard for me to keep track. I don't know if you have another system somewhere that you're keeping track of, but I only see like
Well, I create the ticket.
on the mailing list, right? Or is there any
No,
other
no,
place?
in the ticket tracker, but they never send it automatically to
Okay.
the mailing list.
Okay.
So I send it manually in order that everybody can read it.
But okay, we'll
Okay, so
provide
because like
the
I
pointer.
didn't see the link between the R-bit issue here and like that is going to be fixed using issue 12 somewhere. So
You mean this says 12, and what does it have to do with 12? Is that your question?
no, for the R-bit you said it's like we're going to address it in 12, right? Or no?
Yes, I said 15. I said this is one ticket which was this draft should have a list of parameters that the other documents should remember to specify. The things that we are deliberately leaving open that need to be
It needs to be updated because today is in version 7.
That's fine, but I cannot see like, when you talk about the R-bit saying like it's addressed by like 15 or whatever number, it's like I don't see that linkage anywhere.
You don't see it where?
Okay, go to the R-bit.
Right. So we're saying this document does not specify R.
Okay.
But there should be a section like an appendix, which says technology-specific documents. Please remember to specify the value for R or the mechanisms that you use to number rule IDs.
Okay, so you're going to, on the change log for the next rev, you're going to say this is going to push it to 15.
So there's going to be a section containing the list of things that this draft leaves open for technologies.
But for
with
15,
fragment.
you're going to say it's pointing to issue number, this is resolved by the solution to 15. Is that my question? So okay.
Yes.
Okay.
Okay, padding. So Anna, tell us how much.
So, just one thing. If you have like one point that you would like to solve here, that
Okay,
would be a
last
good
minute.
point. No, I mean, you maybe have 5 minutes, but just pick the one that you would like to address
Pick
of
the
the
one.
issues.
Okay. Well, this one.
This one is because it does
No,
make a
but-
lot of confusion. No, you don't like it. We give. We are almost finishing.
Well,
I sure this doesn't say anything, so everyone is okay with this. No. no.
well, we can always address them on the mailing list, but which one would be the most? I'm trying
For
to
me,
pick the one that's
online.
most difficult to explain on the mailing list.
Oh.
Yeah, this one is a nice one. Okay, let's. Okay, guys, this is your desktop.
Can you put the next one? And no,
No.
differ. Yeah, this one. So the
Okay,
act
let me
format with-
let me explain what the thing is, and now you explain the solutions. Yeah, we have two ACK formats. There's ACK for windows that are not the last one of a packet, and there is the ACK for the last window of a packet. And for the last window, we have a C bit, which tells if the MIC checked OK or not, because we think we've reassembled the whole packet. And so we verify that assumption by computing the MIC and comparing it to the one that was sent. And if this matches, we send back a C bit with a value of 1. If it doesn't, we send back a value with C of 0. So this is the way we know the transfer of all fragments is completed okay. And so we have the fragment format has one more bit for the last window. So we're sending windows of fragments getting ACKs for each window, and the last window gets an ACK, and this ACK has a slightly different format than the previous ACKs for the same flow of fragments coming from the same packet. And this fragment is, this ACK coming back has one more bit. Is it a problem or not? So yeah, it may be a problem. When is it a problem?
I don't see the problem, but okay. But we add this C bit, and what this do is that the window in the last, the last window is shorter than the other window.
There are cases where this is no problem. If your L2 has a payload big enough to accommodate for all bits, you don't care. You have one more bit, so what? Okay, just send this one more bit. Now we are discussing the situation where your L2 payload is kind of small and you're trying to optimize its use. And so we're discussing, fitting ACKs into the L2 payload. And now we have this last ACK that's one bit bigger. And this one bit bigger might be a problem if you're trying to fit a short payload. So we are discussing the case where this one extra bit is a problem. What should we do? So there are two options.
There are two options. The first is we make only a warning as it is today, saying that the last window is having one bit less than is shorter, and then the implementer has to adapt this bitmap to this smaller window, but the last smaller window.
So let me rephrase that.
No, go ahead, because we don't have time. And the second option is
Shepherd.
no,
Come
but
on.
we don't have time. And
You're
the
the
second
sheep.
option is we specify the last window uses, and then we reduce in all the fragments, in all the windows, one fragment. So in all 0 windows, we lost one fragment, and we have the last window complete.
Okay, so option one. We don't change the mechanics that's in place right now. We just add a warning note in the text to implementers or technologists or whatever and say, pay attention to this extra bit. It might bite you. No, bite is not the right term. Sorry, it might hit you. Just pay attention. If you're short on your L2 payload, make sure your max window FCN is a bit smaller than you would think because you have to accommodate this extra bit on the last ACK. So you will not. Why does it have a link with max window FCN? Because a bitmap that you're sending back on an ACK has a number of bits that's equal to the max window FCN. So if this bit is a problem for you, make sure you don't fill up the other ACKs. Leave space for this extra bit. Another option would be to change the mechanics that's currently described by this draft, saying the last window is an exception to the fragmentation mechanism. The last window will not send max wind FCN fragments at most. It will send at most max wind FCN -1. And we know both ends know that, so we create that extra space for this one extra bit. And so we're changing the mechanics.
Yeah, but when you create this extra space, you are losing one bit in the old 0 windows.
No, that was option one. What you just said applies to option one. Now, option two, for the all 0 windows, we still have the same number of fragments. So we're utilizing the full bandwidth both ways. And we create an exceptional processing, which is the last window has a different processing. It has a different bitmap size. So we create a space for the C bit. Does anybody have an opinion on that?
Carlos Gomez. So did anyone ask or object to the way how it is currently in the document?
Well, we got comments. Can you explain? We have a sentence in the draft that says something about this extra bit and something that people should be paying attention. So we got the comments. What do you mean? What exactly should we be paying attention to? And so I'm trying to explain you what we should be paying attention to. And then during the discussion, once option two emerged, that we could change the behavior of the machine such that people don't have to pay attention.
Because, well, maybe being an author, I'm influenced or whatever, but I think what currently the text explains should suffice. I mean, I don't know if
so you're advocating for option one, and maybe we can make the sentence better so that people don't inquire.
Yeah.
Okay.
Maybe.
Any other opinion?
I think that the option 2 is maybe too restrictive because it will not happen often. Because if you have a bitmap FCN of 3 bits, then you have a bitmap of 5 or it's 8 bits. So it's not that big. So it fits in most of the answer. So it will be a very, very rare case. And in this case, maybe it's better not to use over the NOAC or something. So I don't think it's a problem. I think we should document it, but we must document it, but not.
So yeah, so you second option one. And what I heard you saying also is reminding people that we are discussing this special case where you're very constrained on your L2 payload size on the return path. And so that this extra bit does matter. And so you're saying in most situations, most technologies, this extra bit does not matter, and we're discussing something that nobody cares about. So rather than changing the mechanics, you're suggesting changing a sentence, an explanation sentence in a draft. So I think this is pretty clear.
So, a short question about that. Can this be solved also in ticket 15 to say to technology, so the information that is requested by technology-specific documents, to say, well, please take a look at this and put a sentence in your technology-specific draft. What do you do in this case?
Okay, so if the working group decides we go option 1, then you're right. We can add this into ticket 15 to be explicit, have an explicit warning to the other draft. If the working group decided to go option 2, then we would need to change the state machines and everything. But what I'm hearing right now is option 1.
But Dominique, I mean, if you want to leave an option to the specific documents, then you need to provide both options so to let them
No.
choose. And you don't want to do that, so you have to pick one.
Right.
I mean,
right.
you can't leave. What can you tell the other document? They can do anything. There is no option left for them unless you provide the two of them. And nobody seems to encourage you to do
What
that.
Alex said is that if we go option 1, we have this
Warning.
warning to be written, and so it could be added to the list of things that the technology.
But there is no to-do associated, right? It's just a warning for the writer.
Just
but
write a warning.
But they can't act on it.
No. It's well.
They can't make a tuning decision on their stuff, right? They can just limit what they do, but
Okay, so you say it doesn't belong to ticket 15 because.
well, no, it does not. I think
Okay.
we're all set. That's what I would think.
Okay, I think we agree on what needs to do is to write a warning.
Oh, okay. So one, maybe if you have one last word on this one, I'm on one last slide
Okay.
before we move on to the next.
Okay, so we'll go to the mailing list with all the other issues. We'll sum up the discussion we have. The good news is I've probably given you the impression that things are fuzzy, but the good news is the protocol is stable. Actually, we are discussing explanations of what is going on and not discussing what is going on in most cases. And so we are not changing the mechanics. And this is a feedback I get from this session as well. So this is good news. And so my role is to try to have a text that is as clear as possible as to what's going on within Czech. So we're going to address all the issues, propose new text in version 11. So we kind of figured that would be in 3 weeks from now. And we'll go for another round. So if you have more comments, if 11 is not good enough, we'll rev it up again.
Okay.
Yep.
Thank you.
No more questions.
Thank
so, Julien?
And what is the Laurent? What is the process after the publication of draft 11? We do a last call again, or it's no?
There was nothing much which justifies having to do a last call. We are fixing the last call problems, but we never opened a big door. I don't think so.
Okay.
So discussion. So I don't necessarily need another last call, but if you just say like new version is posted, just look at the new text and just like limit your like short, let's say like 1 week last call to just the new text. That would be okay with me as well, in case you want to do it, because people who don't like this fix, who are probably not in this meeting and right, like they can see it because. So like this is what I was saying before for the issue tracker, like there's no change log in the document and there's no versioning in the issue tracker. So there's no way, like I cannot go and look at this thing and say this was fixed by version 11. It's not there. Like because I did the query and there was nothing turned up, right? Like, so we need to make sure that like the link is made one way or another, either in the tracker where you say it's fixed in this version or in the draft itself, the change log saying I fix issue 15.
Yeah, I understand that.
Okay.
Actually, the slides have some information like that, so I will ask the authors to reflect what you have in the slides, like this was fixed by version blah in the tickets.
That's fine. Like I'm just saying, like for people who are not in the meeting to follow this, right? Because the last call will be on the list, and like if somebody is not here who's not following this, like they need to somehow correlate these two things. And as long as you do that, I don't need a full last call for this.
And so with this, we invite Julien. Thank you, Julien. Do you have the? Yeah. Okay. So let's fly. I will ask you to be quicker. You have 10 minutes, but if you can.
I'll try. So I'm Julien Catalano from Killink. I will present the Chic of the LoRaWAN draft. So I'm one of the author with several people. So that's the first slide. The status of the draft is that we set up a task force with the help of our chairs, who invited some people from the LoRa Alliance last time. So they did a good job. So thank you. The task force is led by Semtech, who, as you know, might know that they are the inventor of the LoRa and the leaders of the technical committee of the LoRa Alliance protocol. So the company involved in this work are Samtech, Aclio here, with Evalue also, Actility with Alper Yegin, who is not here today, Kelling with myself, and Vincent with EDF R&D. So we are quite a good group of people knowledgeable about LoRaWAN. So that's good news. So first of all, I wanted to make a status about what's new in 01. So first of all, we added the architecture chapter, summing up how the LoRaWAN is mapping to LPWAN entities. So on that chapter, we suggest where the SHIC compressor, decompressor, and the SHIC fragmentation should be performed. So on the figure, you see this is a typical LoRaWAN architecture network. So with the end devices which are running the SHIC compressor, decompressor. Then we have a transparent gateways and network server for our case, and the SHIC compression, decompression, and fragmentation should be also held in the application server right on the right-hand side. So this is typical LoRaWAN, and this is where we are intending to put the SHIC layers on top. So what is next? What we are discussing together is the LoRaWAN SHIC role are being defined. So we are right now working on one IPv6 UDP with 0-bit sent on the wire. So the goal here is to prove that the technology is really compressing the payloads. All the fields on those rules are not sent. Other rules are defined for CoAP, so IPv6 UDP CoAP for uplink and downlink post. Same thing for GETs. So we are trying to describe how to do hand-to-hand CoAP connection with a remote server. On the fragmentation part, we are also defining parameters. So we have 3 types of fragmentation parameters. One is for uplinks, which are different constraints as for the downlinks. And the downlinks has been separated in 2 parts. So in LoRaWAN, you do have a downlink class A, which is for very constrained devices, which are not listening all the time, but only opening a listening window after transmission. So the fragmentation here must be adapted for such a case. And the downlink for class B and C. So class B is for devices which are listening periodically, and class C is for constant listening devices. So there the fragmentation can be a bit more relaxed, and because we can address the device directly. So that's why we did a specific case for that. My final slide is what we intend to do as a LoRa Alliance goal. As I said, what we want to do is to do an HTTP post from an end device. This would be the result of a good SHIC usage on the LoRa Alliance or LoRaWAN network demonstration.
Dominic Martel. HTTP post from end device. What do you mean? Which is the end device? I mean, on the internet, on the LoRaWAN network? Okay, why HTTP? Is that on the LoRaWAN nomenclature, end devices are the small things which are running on the radio link. So that's like your device with the Semtech radio.
Do you mean CoAP? You wrote HTTP.
Yeah. So actually, the final goal is to have a conversion between CoAP and HTTP at the end. So the idea in the air is to make your end device post something to Amazon Web Services.
Okay,
right?
So it's HTTP on the network side and CoAP on the device side.
That's right. Yeah.
So not quite end-to-end HTTP.
Well, yeah.
I mean, okay, I understand what you mean.
Okay, thank you. So what we foresee as a group is that to do that more in an easy fashion, what we would need is a SHIC rule file format to be loaded on our application server or on a SHIC compressor decompressor. That would mean that the rule could be provisioned as a device profile thing, and that would make all the application server defined in the LoRaWAN compatible with each other, and then we do have compatibility end to end. So then the SHIC is really a standard as a LoRa Alliance LoRaWAN application server. So that's it. Thank you.
Very good.
Quick, Juan Carlos Zúñiga, one question. So just to confirm or understand the question from Dominic, in this in the group, you are not planning to have something like HTTP over SHIC or something. You
No,
would
no,
rely
no,
on
sorry.
the-
I see it's confusing. So we want to do co-op from the end device to the application server, going out with SHIC, and then co-op to HTTP after that.
as it's done
Yeah.
in the
Yeah, I know,
co-op
I
and
know. But
HTTP
the final,
mapping,
the big picture is my device is posting its temperature sensing to the cloud.
Okay, thanks.
That's the goal.
And conceptually, we often have a proxy of some form at the compressor because some numbers have to be matched and things like that. So the proxy can be a very simple proxy which puts the right numbers from the short numbers and things like that. Or it could go all the way to an HTTP to co-op proxy. In this case, you would go all the way. Works.
Yeah.
Perfect. Yeah, perfect. And so I think we'll be,
Thank you.
we are addressing some of these things in the rechartering discussion at the end. So thanks very much for actually bringing these points here. Perfect.
Suresh, we, if the frame is fragmented, then we've got a very large checksum because we are checksumming all the fragments together, and we also have the quote unquote checksum of LoRa at the end of the frame. Now, if the frame is very small, it's just one packet fills in one frame, then the only checksum we get is the LoRa checksum, and we elide the UDP checksum. So that's gonna be always this discussion. Just make you aware. But it's the case where it looks weaker than with a UDP checksum in line is for very, very small frames. So can we prove that the LoRa checksum is good enough to elide the UDP checksum for that very small frame? That will be the discussion.
Answer is Christian. So I think you need to write it up because when we did the UDP checksum 0 for V6, right? Like we had to say, okay, this is going to be the bit error rate and these other kind of things. Like there could be cases where the UDP port could get changed in transit and might not get detected, those kind of things. I think we need to do the same thing because I personally think the applicability statement we have today for UDP 0 checksum doesn't apply here because that was really meant only for tunnel endpoints. So you're saying that
we already have an exception there because if in 6LoWPAN, we already elide the UDP checksum because we claim that we have additional MIC in the messages which give us the same strength. So at the end of the day, it just placed somewhere else. And but this is because we have the same strengths globally.
I think it's because it came before this issue came up, really?
No, it came after. It was right after. It was the same time frame as the tunnel thing. And it passed. I mean, it's RFC 60. Well, we'll
yeah,
so
this is RFC 7 something, I think. So
6021, which discusses that.
Okay, we can talk about it offline, I think.
Your awareness.
Because I think if something is written up already for this, it's okay. If not, we need to write something up for it. We cannot just do the analysis internally and just leave it because at some point somebody from the transport area will say hey, how is this going to work? So we need to either point to some existing document where it's been done or write something up. And I really think we need to write it up because I'm not sure there's existing justification for this. So point it out if you know of something, we can look at it.
Well, 6282 has this same description, but yes, we'll take it offline.
So just to corroborate on this point, I think that could be a useful input for ticket 15. Now I think I'm going to remember this ticket. So ticket 15 for technology-dependent documents to write up that the authors must ensure that the checksum of the technology is strong enough to fulfill this or provide some justification about this. So this way, the people from, we need to have a discussion on the specific technology.
But that's not sufficient. So my thinking is this, the link layer technology provides checksum for that hop, right? But if you're going past that hop, where UDP is supposed to be. So we are trying to relax, if we can relax it for a specific one hop thing, it's different than saying I'm going to relax this for UDP, right? Because UDP runs over the internet. You cannot say hey, my Ethernet checksum is good enough, right? Otherwise that's the original argument. People say, hey, my Ethernet checksum is good enough, but what happens if a router corrupts something, right? So we need to think from the perspective. We cannot just say hey, if the link layer is good enough, we can do it. So that we need to be careful. Let's actually do the work and see how things go.
Let's go offline, but we need to do the work.
Okay.
With this, Juan
Yeah.
Carlos,
Okay.
you want to present us?
So, hello everyone, Juan Carlos Zúñiga, Sigfox, and I'm going to talk about the SHIC over Sigfox update. So again, it's an early draft, not much content so far, but a lot of discussions and testing going on behind the scenes. So what we're trying to do is optimize the parameters that we have to define now that we know ticket 15 will be our reference. So basically we're trying to answer ticket 15 even before it's been created. So what the draft describes is a network architecture, similar what was described before for LoRa, the SHIC rules and the fragmentation. And of course, we're trying to optimize as much as possible because of the small payloads. So a quick reminder also, the generic architecture on the right-hand side, we talk about radio gateways, network gateways, servers and applications, and the Sigfox network architecture, because we have all the base stations connected to the single cloud. The output of the cloud is indeed HTTP, and therefore we have to adapt differently. So any SHIC compression, the compression function would be after this cloud, and therefore implemented after the callback of the cloud. Still TBD whether the cloud will provide a SHIC specific API or connector or not, but so far it's HTTP. And the device, of course, is open for the implementer. So where we're putting attention in this over the past few weeks and at the hackathon is on the optimization of the rules for the most common type of Sigfox Lpwan applications. So that was part of the questions I was asking, the rule ID size and the rule ID world, because we do want to optimize and make sure that we can use the minimum number of rule IDs to optimize this space. As you know, and we talked about, we have this 12-byte uplink payload size that is variable. It could be 1 bit or multiple bytes, but variable to optimize the size of the packet. On the downlink, we have this 8-byte constant payload that it's uplink triggered. So pretty much similar to the Class A LoRaWAN mode. And of course, we need to optimize the padding again to make sure that the messages are consume as little energy as possible. So again, this is post hackathon. My hope is to start providing some recommendations for the next version of the document, specifying those parameters, optimizing them for the better usage. And it's ongoing work. So if you are interested in contributing, please let us know. So far, we have a good number of people trying this out and trying to come up with the best recommendations. Any questions? Okay, thank you very much.
Thank you, Juan Carlos. So, and Edgar.
Hello, I'm Edgar Ramos. I work in Ericsson, and together with Anna and Soti, we are starting this draft, which is saying that Sigfox draft is basically just the beginning. It's a container. There is not that much text on it. But then I wanted to present just some of the issues that we will have to deal with when we are working in this draft. Some of the things has to do with the peculiarities, if we want to call it like that, of narrowband IoT and how it's different with respect to the other technologies. And then there are some architectural issues that I have called. One of them is the different transmission modes. So basically in narrowband IoT, you could have different ways of transmitting data depending on the state that the terminal is, if it's in a connected state, or is it just starting the transmission, or it has been connected, but then it went to power saving mode. Then we have also it depends on the configuration of the operator, so how the operator manage that terminal. So remember that narrowband IoT so far is over license spectrum, so the operator has a lot of even legal responsibility over how it is handle those connections. The bidder handling has to do pretty much with the same of the transmission modes. Since they are different transmission modes, the UE might, the equipment might go from one mode to another, and so that is more effective depending of the, let's say, the buffer size that is for the data that is going to be transmitted. So then it might be changes that you start in one transmission mode and then you switch to the next one, which is optimized. The other thing that Narrowband IoT is quite strong, or is one of the strengths, is the mobility. And here I'm not only talking about mobility in one network, but also you have to think about mobility from roaming. So when UE suddenly wake up in another country and it has to attach and have data to send. This is, for example, a use case for containers, which might have sensors and are traveling in the sea or by plane. And finally, there is a possibility that we could also include cases for LTM that has been specified very recently. It's a type of terminal for LTE, which is also targeting a machine type communication. And then also 5G NR, so the new radio, MTC, which there is not so much yet, but it's starting some work already of what would be used for machine type communication. Then the idea, well, this is about a little bit more detail about the transmission mode, if anyone is interested. And you could say that there are these two types of transmission, the data over NAS and the connected mode. And the difference is that the way how the lower layers protocols works, for example, in data over NAS, they are very much deactivated. So there is where CHIC could work pretty much with all the features. So there you could have fragmentation. There you could have the full set of features. Meanwhile, in the connected mode, there is encryption in PDCP. Well, I can show a little bit this figure, which is the architecture, and then the two stacks. So, which one it is? So for the data over NAS, you will have this stack. Basically, even when you have PDCP and RLC, RLC is a layer 2. Well, we don't say that it's layer 2, but something between layer 2 and layer 3 protocol that could handle reliability. So you could configure it to be reliable or not. For narrowband IoT, now in release 15, they are including non-reliability because it was for release 13 and 14 was only use reliable. So, but now there are some cases like streaming where you might not need to have acknowledgement. So then there are now for release 15 bringing it on. Then you have MAC, which have a HARC protocol. So it means that you have automatic retransmissions, and that is configured by the operator, how many retransmissions want to have. And even when there is some sort of reliability, depending on the channel quality, so those packets might be lost. And then basically you have two layers of reliability in the connected mode, which is what you have here. So here, these two provides reliability. And also RLC provides fragmentation or segmentation, as we call it. So that means that in the connected mode, the fragmentation wouldn't be needed. Now, because this architecture, it means that you would have to have for each of the modes different placement for the compressor and the compressor. So basically, you would have one compressor that works for connected mode in PDCP level here, and then for the data over NAS, you will have it basically here. So these are things that we need to consider. And then again, how you switch from one mode, so you are transmitting in this mode, and then you get upgraded, let's say like that, to connected mode, then what happened? How that transition is done is something that we have to think as well. Additionally to that, well, there is basically ticket 15 that I have copy-paste some of the parameters that were already there, which we have to take care. And the padding treatment, we also have padding treatment in layer 2 for the connected mode, which means that maybe we don't even want to have padding at all for SHIC. I mean, the padding will be handled by the lower layers. And then this thing of the rule ID. So what happens if there is no fragmentation or there is no compression, and then is it really adding overhead, and how you handle that? I think it's very important to have this possibility that it can be variable or it can be defined in some way, how the rule ID size or how it is marked. So it can be that if you start with 1, then you have to read something else. If you start with 0, then you know there is no compression. But well, that's something to look at as well. And that's all I have, I think. It's just not working.
It's a great start.
Juan Carlos Zúñiga? Sorry.
A very quick one, Juan Carlos.
Yeah, well, I'll ask both at the same time. And for the connected mode, well, I assume the CIOT covers both LTE-M and NB-IoT. Okay, so, and then the question is, for the connected mode, are you is the idea to have some IP in IP, or are the IPs completely independent, or how did you match that?
Yeah, that's a good question, because of course, if we do this in let's say PDCP, this means that it has to be standardized in 3GPP. And then in that case, you would use the IP of the terminal, which is the one that is given by the packet gateway.
Right.
If not, then we have to think if it's possible to use it in other way, but I'm not sure at this point. I cannot really answer.
Okay, thank you.
Perfect. Thanks. Thanks very much, Edgar. Thanks very much. So we move on with ICMP. And this one. Okay. Today we have a lot of duos that are presenting. That's good. Very, very fast. Okay. I'm Diego Duchovne, and one of I'm the co-author of the draft from the ICMPv6 NCMPv6. Okay. Then what do you want? We have published. Okay, we go. In this version, we have built a new version, a new rule. Okay, since at the beginning, okay, we started with this variable length. Okay, and then we were told we should keep the rule ID as a whole thing. Then we can go back now to the length, which was already shortened depending on the number of bits. Then, since we were implementing for the ICMPv6 on LoRa, in fact, okay, we have the specific message there as an example, and then we are building a LoRa gateway table, okay, just to specifically on LoRa in this case, okay, because our implementation works on this, and then we are going to go up there and upstairs maybe, and define how it will work as a proxy. And well, on the CHC, okay, we are avoiding the checksum, okay, because we are relying on the packet CRC itself, and you are in fact using the compression table for the other types of packets we are using on CMPv6. And okay, the other thing, okay, we are trying to redesign the strategy, in fact, to reduce the number of packets. Okay, that's the idea we're going through. Okay, maybe most of the work on CMPv6 should be on the proxy side. Just that. Okay.
Okay, and still on ICMP group. Another group wrote a draft before Singapore on ICMP as well. Okay, not working. Next slide, please. Alex. Okay. So what did we do since IETF 100? We have not advanced the draft at all due to lack of time and time spent on other things, but we did prototype ping proxy on the server side. So we had a demo recently where we could ping LP1 device from the outside and have the proxy respond on behalf of the device, and we chose to implement a simple time threshold. If the device has been seen for the last 10 minutes, the proxy will respond with an echo reply, otherwise it will not. So that's one of the proposed behaviors for ping. We've been discussing with Diego on merging the two drafts since Singapore. We haven't done that yet, but we know what's in each other's draft. In this draft, we're interested in RC4443, which is only the ping and trace route behavior, not so much for 861. And I know the chairs have a surprise for us anyway. That's it for me.
Okay, thank you very much. So do you have any questions or like one question maybe, please?
It's not about this draft, but I wanted to just announce that in IEEE 802 wireless, there is now an LPWA group. It's been approved, and we've set some project goals for the group, and one of them is to have header compression draft for 802.15 for depending, it could depend on various things, but I just would invite if anybody here is interested in joining that effort, we're definitely interested. I presented about the SCHC at the recent meeting of 802 Wireless, and there was interest in that.
Sounds perfect. So we'll be looking for another presentation for the next IETF, another submission. Thanks.
Suresh Krishnan. So just to Dominic, so you said no 4861, but that's a legal type in 4443. So you're going to just go for a smaller subset of types that you want to compress? Is that the goal? Because I didn't understand that statement. Right, like the ND messages are legal ICMP messages, right?
Right.
Okay.
I meant only those ones that are defined explicitly in 4441. 4441 does not preclude the other ones, but
okay.
What I meant is that's a type of messages we are interested in this draft.
Okay.
Not to say that.
Okay.
Right.
Okay. So if I understand you correctly, you want to take a subset of codes that are in the INR registry and compress them. The rest of the ones.
I think if you remember last meeting, this draft is also about use cases. Why do we need that? What situations are we looking at? And not just compressing things and sending them over the wire, but what kind of behavior do we expect? If a request comes from the internet to the device, shall we transfer that to the device or respond as a proxy?
Mm-hmm.
And so the draft is discussing all those situations more than providing compression, and Diego's draft provides the compression details.
Okay. So no, but the thing was, like, I was talking to Alex a little bit before, maybe 6 or 7 years ago, we were thinking of doing new ICMP types, for supporting this IoT stuff. So one of the things was, I started writing up something which said, if you're on a cellular link somewhere and the device is on a sleep cycle, right, you would send a different ICMP message back than the regular ICMP messages. So I would really like to see, instead of saying only 44, 43, to have a listed set of ICMP types that we want to compress and do each one separately. So it's it's not a big difference, but I want to not restricted by what is in 44, 43, but rather say we look at a subset of ICMP types. Okay. Does that make sense?
Yep.
Okay.
Well, we'll discuss that at the recharter because that's exactly the topic anyway.
So I think that so
we're out of battery.
Yeah, we're out of battery. So too many slides today. The batteries are out. So I'm going to do this in 2-3 minutes, but it's super important to prepare for what is going to come. And this is data models for SHIC. So basically, how do we do that's an issue a question that we'll need to answer here at some point. And this point is coming very, very rapidly. So Pascal, next slide, please. So we need this because we need to be able to have interoperability and to express this context, among the devices, among the network elements, and among the different technologies. So we have this beautiful table, and there are some beautiful values out there. Next slide. So today what we have is we have some ad hoc JavaScript, ad hoc JSON description, something like this, that works pretty well. But the thing is, that we will need to go a step further and really formalize this thing. Next step, yeah. So today what we are doing is, well, we have the device, and on the other side, the thing that here is called client. So we have the context that today are pre-provisioned, and this way it works. Next slide. And today these are pre-provisioned, and what we'll need to have is the way to do to enable discovery of how the client or the device, is going. The client at least is going to discover what the device is able to support and what are the contexts on it. Also be able to do runtime modifications, minor modifications, if this is necessary, right? We need to have the mechanism, which is not obligatory to be had in all technologies or in all devices, but we need to have this thing in mind, and we need to have this technology. And we'll end up with more things about this. So next slide, then we need to have, this puts us in the position that we need to have a schema for how we are going to be presenting this context, right? To be able to validate all that stuff. And at some point, we'll need to have this protocol for the exchanges between the two so that they're able to do this runtime. Next. So one possibility is to go with Yang. And here, I'm really sorry, Pascal, but I try to have animation. So you'll need to press a couple of times. So we have netconf, go ahead. And in netconf, we have this, and in restconf and in comi. So if we have the Yang module, the Yang model, then you have the representation and have the expression of XML in JSON and in CBOR, how you are going to be able to express the context. So you have we have one schema that for the context, and we have all these representations and protocol bindings. So there is already a solution, Yang and comi, and it works really well. And we are not going to start from scratch. So there has already been a submission. I think it could be a good starting point, and this is something to look at. It is not the only way to do it, and that's a thing for us to study as a working group to decide pretty rapidly. So we have a starting point, we have something that could work really well, and the alternatives are basically we can go with raw JSON as it is for the moment and say, well, now this is the structure that we expect to be, and that's it. We can do it with CBOR, we can imagine some binary encoding, and we can use CDDL to do the validation and so forth. And we can also go the route of defining our protocol on the SHIC level to say, well, these are the exchanges, and this way, we put some configuration and so forth. So these are alternatives. But the point here is that we'll need this document, and right now when we're nearing up the finalizing of SHIC, then it is the time to look at this. So that will be the next point. So if you are willing to contribute and to yes, you can switch to the next presentation if you want. If you're willing to contribute and if you're willing to look into this, now is the right time. So there is already a way to go, but that's a thing to discuss on the mailing list. And
any question? No.
Yes. Do you have any questions or any remarks on this? Yep.
Julien from Kelling. So as I said in my presentation, I fully support such initiative. Thank you.
Perfect. We will be very happy to work on this. And Peter?
Peter van der Stok, I will be very pleased to see some consequences of the choice. What will be the sizes of the files, etc. Because when you optimize by hand, you can come to better results possibly. It's maybe more work, but I would like to see something like that. Okay, thank you.
Yes, Peter, most of this exchange is not to go over the Lpwan itself, right? It stays on the network, so probably the size is not as critical. It could be important, but not as critical as if it was flying all the time over the air, right?
Okay.
I think we'll need to have some, so that's all these are open questions, right? I think that we'll need to have some protocol or something that is able that we're able to configure some values of the SHIC context. So not provision the whole context, but be able to do fine configurations like, okay, I have the context with some rules, and some of the rules I have a value that I want to configure for this device. I need to tell this device. Okay. So
if I understand correctly, so the advantage is the ease of specification, what you're looking for.
Sorry, can you repeat this? I didn't.
Sorry about that,
Yeah.
Peter van der Stok. So as what you're looking for, the discriminating factor is the ease of specification.
The ISO specific.
The
So
language
it
you
is.
choose makes it possible to specify certain structures and complexity, and other languages do not allow that, and you have a certain text and that you have to write. And
So,
for some languages,
yeah.
you have small text to get lots of results, and others you have to write a lot to get little results. So these are the criteria. Is that correct?
I would say so, and I would
Okay.
say also the ease of defining the protocol bindings that enable you to do minor additions, minor patches, let's say,
Mhm.
to the context on the two ends, but also that doesn't put big frontiers to large scale dissemination of this context.
Thank you.
Arke and Ericsson, on the options for different formats, please let's not invent new ones. So definitely use one of the existing ones. CBOR probably good starting point. And as you mentioned on the fetching and patching part, there's a bunch of interesting work done in core also. So let's see what are the synergies there. How can we reuse the mechanisms that we are using elsewhere?
That would be perfect. Oh, thanks. Thank you very much, Ari. And so we are getting into the last part of this talk, and I'll try to do really quick on this one. So we are, as you see, we are nearing up the fulfillment and the completion of our initial charter items, or we might have some of them. So next slide, please. And so these are our two main charter items that we have today. The first one, that is the Lpwan overview, is fulfilling it, and the second charter item that is actually we took really a lot of time with Pascal, and we looked deep down in it in the state where we are, and we actually identified that we were a little bit ambitious when we specified it. So the SHIC over IP, SHIC for UDP IP document is fulfilling the part that is in green, but then we have still the SHIC for co-op. So we would like to make this a new work item, so in the future rechartering, and then we have a new work item that is to include the definition of the data models. So the data models are things that I just talked about. So these will be two separate work items, and we'll have a third one, which is the technology-specific documents for which we talked about today, the LoRaWAN, the Sigfox, the NB-IoT, and the future WISON. So these will be three charter items. So here we have a proposed text that is basically reflecting, getting the previous text, striking out the things that were done, and just splitting this in these three work items. So these things would be sent over the mailing list also, so that we can take a read them, taking a reading of them, if in case you have any comment about this. So that will be this.
And well, staying here. We've got this work that Dominique and Diego just presented right now, on which we are looking if we could derive an actual work item which would make sense. And as was discussed earlier, we don't want to make an exercise of trying to compress ICMP as a whole. We want to have a real use case and a real operation which is useful for the network. And we consider that OAM is actually an important function for the network, being able to go to the device or go near the device and check the network condition, whether the device is alive, whether the network is alive, what's going on. And so we figured that actually the work item behind the work, which was done by Diego and Dominique, was really OAM and some to be defined exactly what we want to do, but taking ping as a reference. And so that's what we wanted to turn into a new work item. So that would be the only new work actually in the charter. So we would take, we complete, as we said, the LP1 overview. We will have completed the SHIC, and around that time, we'd like to be able to have a chartered item around the work which is done on AAM. That's pretty much where we are. Suresh.
Suresh Krishnan. So sounds good. And one other thing I would like is like a milestone update. Like, it still has dates in May 2017 or something. So like just do like a more realistic one because it's not going to be met. So
probably not.
So,
okay, yes, we'll do that. We'll propose you changes as after this.
Something reasonable, because I want to, like, one of the things that's happening is like the telechats are getting like really full. So we have like 1,000-page telechats and stuff, and it's very difficult. So I would really like some heads up on when you expect things to get to me, right? And so if you update the milestones on at least the co-op, because I have like no clue how far off it is. Like UDP IP is pretty close, but co-op I have no clue like how far out it is. Okay,
So okay, so we'll do this, and we got the message that we need to finish we need to deliver the SHIC for IP UDP before we do any rechartering. So that's really important for us to finish this work in time, and that's the first point. On a SHIC over for co-op, basically there has been no advancement because we need, like, a co-op is such a huge thing. So either we will make such a very generic compressor that will be complex and maybe taking too much power and so forth. So the discussions were to recharter, to include it in the next charter, so that we can have input from different users of co-op, and that the authors of the draft can actually profile it.
That's fine. So like if it's say it's not before 2019, that's okay, right? Like I just take an estimate on it, and so just to see how I can, because there's multiple working groups that I have, so I need to make sure that I can plan for it.
Okay. Yeah.
Very good. And so we have 5 minutes for any other business. So, Christian, any other business? Anything you want to discuss? Otherwise, you'll be first in queue for food. Oh, one more ticket, one more ticket. Oh, so blue sheets. Did everybody in this room sign the blue sheets? Oh, please, where are the blue sheets? Please send them back from the bottom to the front. In a oh no.
In full form, please.
Okay, thank you all, and have a great day at the center.
Thank you very much. Bye.
Dominique, Anna, wow. You did such fantastic work with the slides. Wow. And they were coming late, it was kind of anxious, but man, it's such good work.
Yeah.